Hello everyone, let's write our own extra packet codecs using the code that was provided by Turtivorti. Instead of just copy pasting it, I will type it line by line and talk about the class specifics and why things are happening the way they are happening. When you are writing a utility class, you should sit back and think yourself, how often am I going to use this? If I'm going to use it so often, then I should think about a way to make the usage time smaller and make the code work faster. If I'm not going to use it so often, then so be it. I can just call the methods. For example, if you remember, we had written our decoding and encoding for our output item stack payload. Now, keep in mind, output item stack is something that we may want to use every tick. What do I mean by that? This record is responsible of giving the result of a recipe back to a machine or, I don't know, a crafting recipe. At the end of the road, the decode and encode will be called most of the time in every tick in a machine that is crafting something. Although you may have a cooldown, let's say that it will be called 2 times a second, okay? So every 10 ticks. That's a lot of method calls for decoding, and don't forget, we may have to send this payload through the network at some point to sync the client and the server. And this can happen without us writing a single line of code because there are ways in Minecraft, especially these days, to sync the data between the client and server without constantly writing your own packets, sending the packets. There are codes that do this behind the scene automatically. So we don't know how often we will call this decode encode thing, but we already know that this is the result of a recipe, and recipes are the things that machines, for example, will use a lot. So if we are going to use that decode and encode method a lot, we should find a way to make things work faster. So instead of encoding and decoding every single time we are calling the method, how about keeping a cache of every encoded and decoded result? And when we are calling the method, the very first thing we do, we will look into our cached list, and if we have it in the list, we will retrieve it and send it back. So we won't waste time doing the decoding and encoding all the time. We are just decoding and encoding a payload only once, and we will cache it in memory. Don't worry, these memory caches won't be huge or big, and it will not cause any memory leaks. They will not hit the garbage collector a lot, so it won't put a lot of lag on the servers and stuff like that. These are optimized by default in Java. What we want is a private static final map. Now, maps are like generics inside C# if you are familiar with it, and this is from Java util. And what we want to map is an int provider type that we don't know the type itself with a packet codec of registry byte buff, and one more thing that we don't know what it is, but we know that it extends the int provider. Okay, so basically, if I send in an int provider type as the key, I should be able to retrieve the packet codec from the cache. That's the whole story here. So we say int provider type packet codec map. No, we call it codecs for short, and this is exactly the name that we have in Tuttivorti's repository, and I think it's okay. So we say it's new hash map, okay, with nothing in it. I will copy it, I will paste it once, and I will change this int provider to a float provider, and then here it is extending a float provider, and the name will be float provider codecs. So these two are the maps that will bind a packet codec to a type, and we can retrieve the packet codec with providing the type. Okay, now the very first method is public static that accepts a generic that extends the int provider, and it returns nothing. We want to register an int provider. So we sent an int provider type of the T, we call it type, and then packet codec of registry byte buff, comma, the T again, remember T here is int provider type, and we call it codec. You can guess what will happen. All we are doing here is adding this codec to this type inside our map. So we say int provider codecs dot put with the key here is the type, the codec. We are sending in the type, we are sending in the codec, and we are caching the codec with the key of type. Same thing will happen for the float. Here it is the float provider, register float provider. This is a float provider of type T. That's it. At the end, we will put it inside the float provider codec. So far, so good. Now, we put things into the cache. Of course, we should have a way to get them back from the cache. So I will say public static that returns a packet codec of type registry byte buff. By the way, if you don't have easy way of typing registry byte buff, you can type RBB all with capital, and you can find the byte buff, or put a U and it directly finds the buff. So RBB all capital with a lowercase u and hit enter. And then unknown type that extends the int provider. This is our return type, and we call it get int provider codec. All we are sending in is int provider type of unknown, and we call it type. Instead of type, actually, I can use key because I'm a C# user, and the word type in C# is a keyword, and it messes with my brain, so I prefer to use key here. And it makes much more sense for me because I'm sending a key, I'm taking a value out of it. All we are doing is returning from the int provider codecs, we get the key. That's it. By default, if we don't have that key inside the int provider codecs, I think it will throw an exception. I'm not sure about it. Let's take a look. Now get throws, class case if the key is of an inappropriate type, or a null point exception if the key is null. In other words, if you don't have it. Here we go. It returns null if this map contains no mapping. So we will have three different things. If the key is not in the map, we return null. If the key itself is null, we will get an NPE. And if the key is not the type of what we are mapping, it will return a class cast exception. Okay, good to know. So basically it can return null here. Don't forget that. We will get a packet codec of registry byte buff, something that extends a float provider, and this is called get float provider codec. We send in a float provider type as the key, and we retrieve it from the float provider codec. Now, do I want to put these two as values because key value pairs makes much more sense to me? Yeah, why not? Okay, so this will be value and value. These are internal API changes, but trust me, you will see this value as the, wait a minute, I didn't like it. Now that I think about it, I prefer to be codec because these are the hints that I will see as the parameter hints. And now key, okay, provider type. That's a better thing, at least not the type itself, but that makes much more sense to me now. Provider type, provider type, provider. As I said, I'm changing these because when I'm calling these methods, I will see hints there, and I want to see the proper hint here and there. Finally, it's time to put our encode and decode methods. Now remember, we have integer providers, so we have to write an encoder and decoder for the int, and we have a float provider, so we have to write an encoder and a decoder for the float provider too. Okay, so we write public static that returns a type that extends the int provider. Okay, we have public static void. This method accepts the byte buff, not byte buffer, byte buff from io.netty.buffer as a buff, and the t here is int provider. Don't forget, we just bound this t type to be an int provider. However, I wonder why it's grayed out. Void public static void. Yeah, I forgot the name here. Encode. Thank you. So this is the encode. Now remember, we have two encodes, one for the int, one for the float. So I will write the float here, and this is the float provider. Now you may ask yourself, hey, wait a minute, didn't we send in a registry byte buff? So why do I use byte buff here? This is the top level. The registry byte buff is an extension of packet byte buff, and packet byte buff is an extension of byte buff. So by using byte buff here, I'm gonna accept any of these three, byte buff, registry byte buff, or packet byte buff, and I will happily encode these integer and float providers. Now to encode them, we will do this. We will say packet codec of type registry byte buffer comma t codec equals to, we will typecast to packet codec of that, yes, get int provider codec. Now we are calling our own get int, and we say int provider dot get type, and at the end we say codec dot encode typecast to registry byte buffer, the buffer, and comma int provider. So what is the problem here? It says that unchecked cast means that, hey, I'm not sure if what you are getting from int provider codec is actually a packet codec of this. And the whole reason is that we are using generics here and generics here. But honestly, we know that we are already using registry byte buff with the extents of int provider. So what we can do here is just add a little bit of annotation on top of this method method call if we so want to, or on top of the class actually. So I can open this line. So I will ignore it, but if you so want to, you can use the inspection, turn it off, or you can suppress this for the class. And what did I do is hitting Alt Enter and then using the inspection and suppress all inspections for class, or suppress this particular error for the or warning for the class. I will use that. And you see that it adds this @ suppress warnings for the unchecked. So it's a nice and easy way of reading things and not bothered with the things. Now you may ask yourself, hey, didn't we say that if we don't get what we want, this will return null? And then we have null here, and null.encode will cause problems. We will see if it works or not. The funny part is that it will work. Trust me, it will work, because we will handle the maps ourselves a little bit later. Okay, so for decoding, I will say public static. Now we need to bind the type to the int provider again, but returns that int provider, and we call it decode. And here we ask for a byte buff, we call it buff, and int provider type of the T, and we call it provider type. Before writing the code, I will copy this guy, I will paste it down below, because now I need to change this guy to float, and this guy is float, and I'm not sure why do I have this typo all the time. Okay, for the int one, we say packet codec of type registry byte buff, comma T, we call it codec equals to, we typecast to packet codec of that, thank you. That's IntelliSense, by the way, it should work for you, but if it didn't, pause the video and type it yourself. And we say get int provider codec for the packet for the provider type. Now that we have the codec, we return the codec.decode, we typecast to registry byte buff, the buffer. That's it, basically. Nothing too complex, you know. We just retrieve the types from the cache all the time, and we call the encode or decode on the type with the buffer. Okay, same sort of deal should happen for the float. So for the encoding, I will paste it there, and instead of int provider, we have a float provider, and here we want to get the float provider, of course, and then we just call the float provider here. And for decoding, again, the same thing. So once you understood one of these, the rest is easy. We want the float provider from the provider type, then we just call the decode on it, and that's it. Okay, are we finished with this? Actually, no. Now, we want a generic tuple. What we have here is something that we didn't use in our class, but I think there is a reason that we have it. So we say public static that accepts many generic types: B, C, T1, T2, T3, T4, T5, T6, T7, T8, and T9. Now, I have a hunch. I think that Fabric by itself was produced providing this part, B, C, T1 to T8. And we are adding more of these as the packet codec of B and C. So we call it tuple, and we open a parenthesis. Close the parenthesis, and this is our method. Now, inside the tuple, we have many more things to ask. The first param is a packet codec of unknown type that extends, actually not extends, that is a child of B and T1 as a second parameter, and we call it codec 1. This is not our only parameter. We have many more. So, comma, enter. The second one is a function of C and T1, and we call it from 1. Now we have to copy this thing and go 8 more times. So this is T2, codec 2, and this is T2 from 2. Keep in mind the B and C remains the same. The next one is 3, codec 3, T3 from 3, comma, this is 4, codec 4, T4 and from 4, comma, T5, codec 5, T5 from 5, this is 6, codec 6, T6 from 6, 7. Believe it or not, this is exactly what we have in Minecraft code, and either they had to write it or the Java developers had to write it. I'm not sure, but this is exactly what we have here. So T9, codec 9, T9 from 9. Okay, whew, that was a long thing. Now, after from 9, here's the fun part. We have another function, but here we say function 9. And you see that it's from Mojang. Mojang data fixers that util. So Mojang and his team had to do things like this all the time. T1, T2, T3, T4, T5, T6, T7, T8, T9. Be careful about typos. And finally C, and this is with capital C, and this is the 2. Okay, remember we had this packet codec and the tuple? That's the same stuff. Okay, now we need to write our returning of the packet codec. So we return a new packet codec, not B and C. It's redundant, by the way. So here we have a decode and encode, and the fun begins. So the decode returns the C, of course. We say T1 object 2 equals to codec 1 dot decode object, or I think we call it buff. Okay, copy it. And the reason we call it object 2 is, okay, I will call it object 1. So T2 object 2 is codec 2, and we have to duplicate it a few more times. This is 3, 4, 5, 6, 7, 8, 9. And I will cheat, hit insert, and I will change the numbers. So this is 3, 4, 5, 6, 7, 8, and 9. So this is again 3, 4, 5, 6, 7, 8, 9, 3, 4, 5, 6, 7, 8, 9. And I finished that. Okay, instead of returning null, we return 2.apply. And you see that this accepts a lot of different things, and this apply is endless basically. So we want to apply the object 1, comma, object 2, comma, object 3, comma, object 4, comma, 5, comma, object 6, comma, object 7, comma, object 8, comma, object 9. Whew! The encode. Hoo-hoo. We have codec 1 dot encode with the buff, comma, from 1 dot apply the object 1. Actually, we call it value. Okay, makes sense. Now we have to add 8 more times. 1, 2, 3, 4, 5, 6, 7, 8. And we need to change the numbers. Again, cheat, insert. This is 2 from 2. This is 3 from 3. This is 4 from 4. 5 from 5. 6 from 6. 7, 7, 8, 8, 9. 9, and that would be it. So at the end, I will put a semicolon here. Now, this was one of the tuples. We'll have many more. The easiest way is to just copy this whole thing and then minimize this and minimize that actually. Come down and hit paste. Now, instead of here, we have a T10. So just add a T10 here. And again, we just copy this section. We paste it. This is T10, codec 10 from 10. At the end, before C, we add a T10, and this is from 10, the function 10, sorry. Actually, yeah, copy one line, T10 object 10, apply object 10. And this is codec 10, by the way. One last line, codec, and this will be 10 from 10. And you get a new tuple here. Why are you yelling at me? Because it says it provided T9. It shouldn't. Let's see. Oh, here we go. This is T10 here. Okay. Now, as you saw, it's just a bunch of copy paste. So I won't waste your time, and I will just copy the whole thing from Turtivorti, and I will paste it down here. And you see that they went all the way to T16. So we have 9, 10, 11, 12, 13, 14, 15, and 16. And these are just a bunch of tuples, you know. So let's close all the methods. And again, it's a repetitive job. And honestly, I don't want to disturb you typing those in front of the camera. But long story short, this is T9, T10, T11, 12, 13, 14, 15, and finally T16. And that's it. These are the tuples that are added. Now, as I said, at some point, we want to handle those two caches, and we want to add our defaults. So we say public static void register defaults. And here we say register int provider with int provider type dot constant, comma, packet codec dot of static. Now remember, of static is asking to provide the encoder and decoder. However, instead of calling methods, now we can send in the buffer and the int provider into a lambda, and all we are saying is buff dot write int. So we are writing an integer from the provider. So int provider dot get value, if I can find it. Here we go. This is our encoder. The decoder would be the buffer goes into a lambda, and here we say constant int provider dot create. Here all we are doing is reading an integer from the buffer, and that's our encoder and decoder, and that's our integer provider. So all we have have in the list right now is a single integer provider. Now, that was the constant type. Don't forget, this is the type. We have another one. I will copy it. I will paste it. But instead of constant, now we have uniform. And for uniform, when we are putting the buffer here, we want to write two things. This is the get min and get max. When we are debuffing it, we are reading two integers. So copy that, paste it. And this is not a constant int provider. This is a uniform int provider. Okay, we have another one. I will get this one. I will paste it. And instead of uniform, by the way, if you want to see all the types, put a dot. You see that we have bias to bottom, clamped, normal, constant, uniform, weighted list, and we have to cover every one of them. So bias to bottom. Now, bias to bottom again has a get min and get max, and here we return a biased to biased to bottom int provider. And by the way, I forgot that I need to put semicolons at these lines. So that's that. Now, after that, we want a clamp. So again, we want to cover another type, and that is clamped. Here we have something before writing the lines. So we say int provider type of unknown. We call it type equals to registries dot int provider type dot get from the buffer read identifier. So we are getting the identifier of the type. Then we say packet codec of registry byte buffer and int provider. We call it codec equals to typecast to that get int provider codec of the type. So we are calling our method. After that, we say codec dot encode with the buff and the int provider dot source. Okay, now this dot source is not working. Let's see if it will fix itself. So here we will say we return clamped int provider. We will change this part. So we say get int provider codec from int provider codecs, int provider type dot constant dot decode from buff. What did we do? We read the first value. This is what we did. We read the first value here as the source. And again, copy this line. Actually, we read the buff dot read int directly now and read int again. So buff dot read int again. And this solved this source. Now remember, this one writes the int provider source into the buffer. And this is exactly reading that source from the buffer. Then we write the minimum and the maximum, so we read the minimum and maximum later. That's the whole thing. Okay, it was a bit complex, but hopefully that will make sense when you read the code later. Then we have the weighted list. Now I will go with this guy again. The one is weighted list now. The lambda, this is not int provider anymore. This is a value because this is a list, I think. We want the packet codec, so packet codec of registry byte buffer and the unknown that extends the int provider. We call it codec equals to get int provider codec for the value dot get type. Remember, we are working with a list. So we are dealing with the types of the list here. Then we have a data pool of type int provider. We call it entries equals to value dot weighted list. Now, here's the thing. Why am I getting errors? Data pool should come from Minecraft. Let's see if I can find it in the imports. So we want to import net Minecraft util collection dot, we don't have data pool anymore. So what do we have here? Array list. I think it's pool now. I think it's called pool now. Makes sense. It's a pool inside the collection. So again, this guy doesn't have the weighted list. As I said, this is not my code, so I'm struggling here a little bit. Actually, I think I'm getting something because it says biased. Let's make it weighted list and let's see what we get now. Now, what is the value here? Weighted list int provider. Okay, let's continue down the road. Let's remove this part. Let's remove this part and let's continue. So after the weighted list, we want a packet codec of type registry byte buffer, comma, weighted list. No, that's not what we want. We want the pool of int provider, and we call it entries codec equals to weighted list codec. We typecast to packet codec of registry byte buffers and the int provider. The codec, again, weighted list codec is missing, but that's our own method, so we will write that in a few minutes. Finally, we say entries codec dot encode, and here we send in the buff and entries. So right now my only problem is this weighted list here. After that we send in the buffer to decode, and here we say packet codec of registry byte buffer, and why are you doing this? Extends int provider. We call it codec equals to get int provider from int provider type dot constant. Then the pool of int provider, we call it entries equals to, again, our method call, we will send in a typecast to packet codec of registry byte buff, comma, int provider codec. And what we get out of it, we call the decode on it with the buff. And that's it. Finally, at the end, we return new weighted list int provider with the entries. Okay, let's write this weighted list codec, because I think if I fix this error may be gone. So at the end of everything, we will start with public static that returns a packet codec, but the packet codec uses generics, so B extends byte buff and E, and we say a packet codec of B comma pool of E, and we call it weighted list codec that accepts a packet codec of B comma E, and we call it element codec. Now I will not return anything, but here you see that the weighted list is still errored. Now you see the problem. It says weighted list has private access. So all we need to do is add the entry for the access widener, and you see that I already had that access widener, but it was for data pool. It wasn't renamed, and I think it became pool. So I have to reload the whole solution and it will be fixed. So let's do that. I will go into Jiralib and reload Gradle project. I will come back when it's finished. Actually, as it's doing its job, why not? Let's continue forward. I will not write the code for this method. Right now we have many more things to cover here. So the other one is clamped normal. Now we have clamped. Let's copy it and let's add it to the end. And this is clamped underline normal. And here we want to write few things. Now we don't need any of this mumbo jumbo. We use buff.write float, and that is the int provider dot mean. Again, we don't have this because if you look, it says that it should be using access widener, I think, and buff.write float int provider dot deviation. Now let me take a look at my access widener, because I have the int provider, as you see, clamped normal int provider mean and deviation. I think if I change this guy to clamped normal, yeah, the error will be gone, because I did the access widening on the mean and deviation on clamped normal int provider before. So we write the mean, we write the deviation, we write the minimum and maximum of the values. Now when we want to create them, all we have to do is just read some floats before reading the integers. So buff.read float, comma, I will copy it and I will paste it again, and this should work. Basically what I did is just write two floats and then two integers. So I'm reading two floats and then reading two integers, and that's it. Instead of create, I have to call the method of. Honestly, I don't understand why sometimes it's using create, why sometimes they are using of. It beats me. Now one more thing before I continue forward, and by the way, the weighted list is fixed because now the access widener is working. If you were an old member of the modding community, you would know that back in old days we had to write packets and send packets directly from server to client or reverse from client to server. And when we were writing these packets, we were doing the exact same thing. We would write data into a packet and then we would read the data from the packet. And this is the same concept. The order that we were writing into the packet was the order that we were reading from the packet. So you see that it's mean because we wrote the mean first. We wrote the deviation second because here we are reading the deviation second. So if it was deviation then mean, I would write the deviation first, then the mean second, because here I would read the mean as the second parameter. That was a little bit of history. Now, after the clamped normal, we are finished with the integers. It's time to register our float providers. Now, float provider type dot constant, and here we are sending a packet codec dot of static. For the encoder, again, we send in a buffer and a float provider into a lambda. All we are doing is saying buff.write float, the float provider dot get value. This is the simplest one. Then for debuffing it or decoding it, we go saying buff goes into buff.read float, and we send it as a parameter to constant float provider dot create. As I said, this is the easiest one. Then we have uniform. So I will copy this, paste it, and this is uniform. The lambda here will become bigger. So we write the get mean and get max. So this is the mean and this is the max. And here we return a uniform float provider, and basically we need to read float twice. If you recall, that's the same thing with writing a uniform integer. However, here we are working with floats. Then we have clamped normal. So I will get this one, the clamped normal for the integer. I will register a float. This is a float type clamped normal. And again, we are writing the min, but here I will call it float, by the way. So float provider goes into mean, mag, deviation, mean, deviation, get mean, get max. And here we are returning a clamped normal float provider, and we read the floats, we read the float. Now here, instead of integers, we read the float, and instead of writing the integer, we write the float. Okay, and what is the problem here? Clamped normal float provider dot here, the create. As I said, some of them use the of, some of them use the create. The last one is trapezoid. Trapezoid is close to clamped with a little bit of difference. So we have trapezoid. For trapezoid, we have the minimum and maximum as the floats, and then we have to add one more float, and that is float provider dot plateau. Plateau. No, Plateau. Finally, plateau. And you see that it cannot resolve, but then here we want to return a trapezoid, and that's it. So the plateau is okay. Finally, we read the float, and we read the third float, and that's it. Okay, now we had read and write everything possible. Okay, here's a question: where do we call these registered defaults? Because as much as I see, we are not calling the registered defaults anywhere. We may want to call it at the statics, or actually we will leave it to the user. Let me think about it when I finish this. Okay, I just copy pasted the last one because it's nothing big, it's nothing huge, it's just returning a packet codec of something a little bit complex. So I preferred that I would explain it instead of trying to type it. And by the way, things has changed between 1.21.4 and 1.21.5. And again, thanks to Turti, he provided the updated code to me. Now, public static, that returns a packet codec of something that extends bytebuf and a pool of something generic, okay? A pool of objects. We call it weighted list codec. We accept the packet codec, and then we call it element codec. So basically, what we want to do is change this packet codec to something that keeps the key, but the value is being changed from the object itself to the pool of that object. That's the whole thing here. So what we are returning is a packet codec of the bytebuf object, and then a weighted E. Remember, E can be anything. And then we go with E and integer. So we have three elements here. Then we ask for a tuple. We present the element codec because we already had it. And then we convert it to the value of the weighted class. This value can be any object. And then we want to go back. And again, we have a weight here because remember, this is a weighted list. So we want to have a value as an integer, and this is why we have the integer here, and that is the weight as the integer in the list. So finally, we instantiate the weighted, and we make a collection out of the packet codecs list. We go for the pool new and get the entries. It's a little bit complex. Honestly, I personally don't understand it very well. I can't explain it very well, but thanks to Turti, basically what we have here is that if you recall where we were using this code, we are making a weighted list of integers. So basically, we have a pool of int providers as entries, and we convert them to a packet codec of the type and a pool of int providers. So we encode it to be a pool of int providers, and then we get that thing and we retrieve the pool of int providers and we decode it on the buffer. That's the whole thing, okay? That's a very complex method call for encoding and decoding a weighted list. However, this is done, and the whole class is finished. Although this method is not being called. Normally, the users of the library had to call it from their mod initialization, but I don't like it. The reason is that if it was a part of code in my own mod, like mod items or anything else, I could just call it, and I can call it as init or whatever. However, as a library out there for people to use it, I don't like it. This class is almost a helper class, and although we have access to put and retrieve different types from int providers or float providers, basically what we are doing is that we are making them final. So instead of having all these problems, we can go with a static block And inside the static block, we will call our register defaults. And this way, whenever a user asks for extra packet codecs.encode or decode, for example, at the very first call of extra packet codecs, these two will be filled with the default values. So that's that. One last thing, these tuples sitting here, again, these were provided as Turtivorti is writing his code. I personally don't like it being here. I think extra packet codecs is all about codecs. And again, these tuples are returning packet codecs. I don't know. I honestly think that I can cut them and put them somewhere else. Also, these shouldn't sit under the util class. These are network stuff. So I will call packet codec tuples and I will add it here, just like that. So I have tuples for packet codecs, and this class is now much neater and more understandable. So I will close that. I will drag and drop it to the network, do the refactor thing, and that's it. So basically now we have the extra packet codec and the errors on the encoding and decoding on the output item stack is gone, and it's the end of the extra packet codec library here. This is a very powerful class for transferring the int providers and float providers for different packet codecs. However, I think the way we are using the payloads and we are writing this library means that people will rarely use these two directly, although they have access to it. So in the next video, we will come back and finish this configured ingredient. This is something really interesting. If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.